Hello everyone. So this is a question from JEE Advanced 2025 paper 2. The compounds with pH bonds is, okay, so this is the catching point. We need to find pH bonds, okay. And they have given us, four compounds, and they are, phosphorus compounds, H3PO4, H3PO3, H4P2O7 and H3PO2. And the chapters involved is obviously P block, okay. So before we are able to draw the structures of these guys in detail, we need to know few things, okay. The first thing that we need to know is the configuration of phosphorus. So the configuration of phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3, right? So this is in the ground state, and obviously it has 3d vacant orbitals, so that is important, okay. So one electron from 3s2 can jump to 3d orbitals, and so it can be promoted to 3d, resulting in a configuration in the excited state. So this is in the ground state. In the excited state, phosphorus will look something like this: 1s2, 2s2, 2p6, 3s1, 3p3 and 3d1, right? And we know that the number of unpaired electrons present, or the number of half-filled orbitals present, is equal to the covalency, right? So therefore phosphorus shows covalency of 5, very important, okay. So 3, 4, 5. So therefore phosphorus shows covalency of 5. So in its commonly encountered compounds, so for example these guys are very common compounds of phosphorus, it shows covalency of 5. Although it can also show covalency of 6 in certain special coordination compounds, okay. So that's a different discussion, but these are very common compounds of phosphorus. So in all four of them it will show a covalency of 5. So using this information, that is the covalency of phosphorus is 5, let's try to draw the structure of each option one by one, okay. So the first option that is given to us is H3PO4, okay. So this guy is known as orthophosphoric acid, orthophosphoric acid, okay. So since you can see there is only one phosphorus, so therefore this phosphorus is the central atom, okay. So first step is connect all 4 oxygen with phosphorus by a single bond. So it's basically a hit and trial technique, okay. In the end we should be able to satisfy the covalency of phosphorus, that is 5, and also the formula H3PO4, that's our aim, okay. So connect all 4 oxygen with phosphorus by single bond. There might be double bonds also, but let's first go with single bond. So therefore we will get something like this. So we'll have P, O, O, O and O, right? And then connect the 3 hydrogens. So there are 3 hydrogens in the formula, you can see. So we connected 4 oxygens because there are 4 oxygen in the formula. Then connect 3 hydrogen with oxygen by a single bond. Next step is, so B is connect 3 hydrogen with oxygen by a single bond. So this will be a single bond because hydrogen's valency is 1, so it will maximum form a single bond. So there is no doubt about that. So therefore, this guy will look something like this now. So phosphorus O, H, O, H, O, H and single bond O, right? So this is not correct, you can see, because the covalency of phosphorus is still 1, 2, 3, 4, okay. So therefore next step is convert one PO to P double bond O. One P single bond O to P double bond O. So in this way, what is going to happen? You will see. If we convert this P double bond O, because this P double bond O is left, so let's convert this P single bond O into P double bond O. So this will become P double bond O, OH, 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 right? So in this way, you can see the covalency of phosphorus satisfied because it has 5 covalency, 1, 2, 3, 4, 5. And also the formula is H3PO4. So there are 1, 2, 3 hydrogens, 1 phosphorus, and 1, 2, 3, 4 oxygen. So therefore this is the correct structure of H3PO4. So this is, a hit and trial method to find out the structures of phosphorus compounds. As you can see, it does not contain any pH bond, right? So therefore this cannot be the answer. This cannot be the answer. Okay, next we have option B. Option B is H3PO3. So this guy's name is orthophosphorus acid. Orthophosphorus acid. It is also known as phosphonic acid. Phosphonic acid. So as you can see, again it contains 1 phosphorus, so therefore this phosphorus is the central atom. Okay, so again, to draw the structure of this guy, what we do is, first step, first connect all the O with P by a single bond. Okay, connect all O with P by a single bond. So we will get something like this. P, there are 3 oxygens, so therefore P single bond O, P single bond O, and P single bond O. Okay, then connect the 3 hydrogen with oxygen by a single bond. Second step, connect 3 hydrogen with oxygen by a single bond. So then this guy will become into this. So we will have OH, P, OH, OH, right? So clearly you can see this contains 1 phosphorus, 3 oxygen, and 3 hydrogen, but this is not the correct diagram because covalency 5 of phosphorus is not satisfied. Here phosphorus is connected only to 1, 2, and 3, right? So therefore what we do is, next convert 1 PO bond to P double bond O. Convert 1 P single bond O to P double bond O. So whenever P single bond O is not working, you can convert P single bond O to P double bond O. Okay, to P double bond O, and add a pH bond. Okay, so basically this guy, what I'm saying is, convert 1 P single bond O into P double bond O, and this H as 1 H here, right? So this will ultimately become P double bond O, single bond OH, single bond OH, and single bond H, right? So now you can see the formula is satisfied. There are 3 hydrogen, there is 1 phosphorus, and there is 1, 2, 3 oxygen, and also the covalency of phosphorus is 5, which is also satisfied. 2, 3, 4, 5. So this is the structure of H3PO3, right? And you can see there is a pH bond, so therefore this is one of the answers. Okay, this is one of the answers. B is one of the correct answers. Okay, now we have next C option. C option is H4P2O7, and the name of this guy is pyrophosphoric acid. Okay, so you can see there are 2 phosphorus atoms, so it might be tempting that we make a P single bond P connection. Okay, that is something like this, and then you connect all these 7 oxygen with phosphorus by a single bond. Okay, so first you make a PP connection, and then you connect all 7 oxygen with phosphorus by a single bond. So this will look something like this. Okay, so we will have P single bond P and 7 single P single bond O bonds. So 1, 2, 3, 4, 5, 6. So there are 1, 2, 3, 4, 5, 6, 7. Okay, correct. And and then connect the 4 hydrogen. Remember, we have 4 hydrogens here. So connect the 4 hydrogen with oxygen by a single bond. Okay, next step is connect 4 hydrogen with O by a single bond. So therefore after that, this guy will become something like this: P single bond P, OH, 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 and single bond O, single bond O, single bond O, right? So you can see this is satisfying the formula. There are 2 phosphorus atoms, 4 hydrogen atoms, and 7, 1, 1, 2, 3, 4, 5, 6, 7 oxygen atoms, right? But this is incorrect because covalency 5 of phosphorus is not complete. So this guy, you can see this phosphorus is showing 1, 2, 3, 4, 5, correct? But this phosphorus is showing only 1, 2, 3, 4, right? So therefore there is actually a oxygen between this phosphorus and this phosphorus. Okay, so we connect a oxygen between phosphorus and phosphorus. So instead of having P single bond P, we actually have a P single bond O single bond P, right? And then we connect all the 7 oxygen with phosphorus by single bond. So 1, 2, 3, 4, 5, 6. So we have 1, 2, 3, 4, 5, 6, 7, right? So you can see we don't have enough oxygen hydrogens. We have only 4 hydrogens. So we connect 1 here, 2 here, 3 here, and 4 here. So we don't have enough hydrogen to satisfy every oxygen. So 2 oxygens are left out, right? So therefore we have to convert P single bond O into P double bond O. Okay, so therefore what we do is we make P double bond O to satisfy the covalency 5. Okay, so we convert this bond into a P double bond O, we convert this bond into a P double bond O. So therefore this will become P single bond O, single bond O, double bond O, O, P single bond O, single bond O, double bond O, right? And then we connect the 4 hydrogens, 1 here, 2 here, 3 here, and 4 here. So now you can see that this guy, it has the formula H4, 1, 2, 3, 4, and there are 2 phosphorus as well as 7 oxygen, 1, 2, 3, 4, 5, 6, 7. Okay, and also covalency 5 of each phosphorus is complete. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so this is the structure of H4P2O7. So it also does not contain any pH. So therefore this also cannot be the answer. Okay, cool. And the last option is D, which is H3PO2. And H3PO2 is known as hypophosphorus acid. Okay, hypophosphorus acid. It is also known as phosphinic acid. Phosphinic acid. Okay, cool. So again you can see there is 1 phosphorus, so therefore it will be the central atom. So what we do is we have phosphorus as the central atom, and then we have 2 oxygen. So first connect all the 2 oxygen with phosphorus by single bond. So single bond, right? And then connect there are 3 hydrogens, right? So you can connect 2 hydrogens, 1 here, and 1 pH bond, right? So so we connect 1 hydrogen here, 1 hydrogen here, and we make a pH bond, right? So you can see this is not correct. Okay, this might be satisfying the formula 1, 2, 3 hydrogen, 2 oxygen, and 1 phosphorus. Yes, it is satisfying the formula, but this is not the correct answer because covalency 5 of phosphorus is not satisfied. So therefore convert 1 P double bond O, convert 1 P single bond O, sorry, to a P double bond O, and add 1 more pH bond. Okay, so what I am saying is convert 1 P single bond O this into a double bond, and this H is as a separate pH bond. Okay, so therefore this guy will become P single bond H, double bond O, single bond O, H, and pH, right? So what I did, I converted this P single bond O into P double bond O, this one, and this POH is the same, POH, this pH is the same, this pH, and this H I made a separate bond with this phosphorus. So therefore there is 1 extra pH. So therefore this is the correct structure of H3PO2. There are 3 hydrogens, 2 oxygen and 1 phosphorus, and also the covalency 5 of phosphorus satisfied, 2, 3, 4, 5, right? You can see this guy contains pH bonds. There are 2 of them. So therefore D is also correct. D is also a correct option. So the question is asking us the compounds with pH bond. So D is one of them, and also we got one more which was B. So therefore the answer will be B and D. Okay. So the answer will be yes, B and D. Okay. Thank you.